You know, when we think of space, we tend to imagine these beautiful, brilliant nebulae, distant galaxies, all that awe-inspiring stuff. But let's be real, it's also a deeply unsettling idea. A whole lot of nothing, possibly an infinite amount of nothing, filled with unbelievable energies, all hidden in a darkness that just goes on forever. It's both an inspiration and, well, a terrifying void. So to really get our heads around this duality, we have to look past the stars and, believe it or not, start with ourselves. To truly feel what the void is, we're not going to start with a telescope. Nope. We're going to start with a single human being, taking what was probably the single most daring step in all of history. Okay, picture this. It's February 7th, 1984. You're about 317 miles above the Earth. Astronaut Bruce McCandless pushes himself away from the Space Shuttle Challenger. And just like that, he became the first human satellite, floating completely free, completely untethered in space. See, Neil Armstrong, he took a small step onto a surface. McCandless, he took a deliberate plunge into pure infinity. Have you ever tried this? Just lie down in the grass on a really clear night and just stare up. If you do it for a minute, something weird happens. Your whole perspective can flip. You're not looking up at a ceiling of stars anymore. Suddenly it feels like you're looking down into an endless abyss. And the only thing stopping you from falling forever is gravity, just holding you to this rock. So that feeling, it actually has a name, astrophobia. And it's not just about old superstitions, like thinking comets were bad stars, which, fun fact, is literally where the word disaster comes from. Disaster, bad star. No, this is a much deeper, kind of cosmic existential dread that hits you when you start to really confront the sheer scale of what's out there. But here's the kicker. That feeling isn't just some trick your mind is playing on you. It's the literal reality of being in space. There is no up. There is no down. There is just an infinite fall in every single direction. And the only thing stopping you is this invisible force we honestly still don't fully understand. Okay, so that existential fear, that's one thing. But the actual physical dangers are so much more immediate. I mean, forget about deep space for a second. Our own solar system is almost entirely lethal. Think about this for a second. Even right here, on Earth, our perfect little oasis, we can only really survive on about 12% of the total surface. The rest of it, it's ocean. It's ice, it's desert, or it's dense, uninhabitable forest. Our home is this tiny, fragile sliver of safety in what is basically a vast cosmic shooting gallery. And the most important thing to remember is, everywhere else is worse, a lot worse. On Mercury, you'd either be boiled alive or flash frozen, depending on which way you're facing. Venus, you'd be crushed, incinerated, and suffocated all at the same time. Think of the Titan submersible disaster, but also on fire. Mars would give you a fatal case of the bends as your lungs ruptured. On Jupiter, you would just fall and fall until the pressure squeezed you into a diamond. And on Neptune, it's so cold your body would literally turn to glass. So, right, our solar system is a death trap, but that's just our tiny corner of the cosmos. Now let's zoom out, like way out, and I promise you, our entire sense of scale is about to get completely broken. Let's start on a human scale, 5 miles. That's it. That's as high as a person can go before you just can't breathe anymore. It's a distance you could walk in about an hour. That is the absolute limit of our unassisted existence. Okay, next stop, the distance from our sun to us, here on Earth. It takes light, the fastest thing in the entire universe, a full 8 minutes to make that trip. Now for our real jump, our nearest stellar neighbor, Proxima Centauri. Light takes over 4 time years to get there. We are now way outside the kiddie pool. We are in the deep end of interstellar distances. But even that is nothing. To get to the next galaxy over, Andromeda, would take 2.5 million years, traveling at the speed of light. That is a journey across a chasm of emptiness that is almost impossible to imagine. And when you look at the universe on this massive scale, you see it isn't just random dust. It actually has a structure. It's like a cosmic web made of these huge filaments of galaxies, things like the Laniakea supercluster, and they're all separated by these massive empty regions like the Buote's void. We're talking about a space that is 300 million light-years across with pretty much nothing in it, just empty. And all of that brings us to the edge, The estimated size of the entire observable universe is 93 billion light-years across. At this point, the numbers just stop making sense. And a scale that big, well, it raises a very, very scary question. With all of this absolutely incomprehensible amount of stuff out there, billions of galaxies, trillions of stars, countless planets, why is it so quiet? Where is everybody? This sci-fi legend Arthur C. Clarke put it perfectly. If we're all alone in the universe, the sheer loneliness of it, the waste of all that space, it's terrifying. But if we're not alone, well, that's a whole different kind of terrifying, isn't it? Both possibilities are just existentially chilling. One theory for this eerie silence is something called the Great Filter. It's this idea that there's some kind of universal barrier, an incredibly difficult step that almost no life form can ever get past to become a galaxy-spanning civilization. And the really big question is that filter behind us, or is it still waiting for us up ahead? I mean, maybe the filter is something we've already passed, like the leap from a single cell to a multicellular organism, which took over 2 billion years right here on Earth. Or maybe the filter is still to come. Maybe intelligent life is just doomed to consume all its resources and wipe itself out. Or maybe, and this one is a little sad, maybe the universe is just so old that countless civilizations have already come and gone, like ships in the night, never even knowing the others existed. You know, all this vastness, all this silence, it can feel pretty overwhelming. So let's zoom back in. Let's bring this giant cosmic perspective all the way back home to a single pixel captured by a machine we threw out into that void. So on Valentine's Day in 1990, the Voyager 1 spacecraft, more than 6 billion kilometers away from home, turned its camera around for one last picture. And it saw this, a pale blue dot. As Carl Sagan so perfectly put it, that's here. That's home. That's us. On it, every single person you have ever known, ever loved, ever even heard of, lived out their entire lives. And from that far away, our entire history just looks different. Sagan went on, think of the rivers of blood spilled by all those generals and emperors so that in glory and triumph, they could become the momentary masters of a fraction of a dot. All our wars, all our arguments, our imagined self-importance, it's all challenged by just a single point of pale light. And that really brings us to the ultimate takeaway. This cosmic perspective, it isn't meant to make us feel insignificant. It's meant to make us feel connected. In Sagan's words, it underscores our responsibility to deal more kindly with one another and to preserve and cherish this pale blue dot, because it is the only home we have ever known. In all of this vastness, there is absolutely no hint that help is going to come from somewhere else to save us. We are all alone on this tiny little oasis, floating in a never-ending inky black void, which leaves us with one final, urgent question.